Hello and welcome to Dice.biz. This video will focus on Q&A series on heat treatment methods. These are the topics. Explain what actually happens during heat treatment. Grain structure changes with the application of heat and method of cooling. This induces desired properties in the steel. Heat treatment is a process where controlled heating and cooling of components is made. It is applicable to plain carbon steel, alloy steels as well as non-ferrous materials like aluminum and copper. Treatment enhances properties like hardness, toughness, strength and ductility. Properties are a result of the heat treatment method like slow heating, quenching, air cooling and many more. List the types of heat treatment. Hardening. It refines the grain structure to make the piece scratch and wear resistant. Tempering. It refines the grain structure to restore toughness in already hardened piece. Normalizing. It refines the grain structure to make all the grains uniform to make the piece stress-free and tough. Annealing. It refines the grain structure to restore softness, ductility and formability in already heat-treated piece. Carburizing. It is a heat treatment process in which iron or steel absorbs carbon while the metal is heated in the presence of a carbon-bearing material, such as charcoal or carbon monoxide. The intent is to make the metal harder. Not the whole metal piece but certain outer thickness only can be carburized. Nitriding. It is a heat treating process that diffuses nitrogen into the surface of metal to create a case hardened surface. These processes are most commonly used on low to medium carbon and low alloy steels. Why certain steels cannot be hardened. Amount of carbon present in steels decides the hardenability. Low carbon steels cannot be hardened. However, surface hardening or case hardening is possible by carburizing or niter. Medium to high carbon steels can be hardened. Medium carbon steels contains minimum 0.4% and high carbon steel contains minimum 0.8% carbon in composition. Explain normalizing in detail. Here the metal is heated above upper critical temperature. Normalizing is post-process on steel forgings or castings. It refines the coarse grain structure occurred during forging or in casting while solidifying. It makes more uniform and fine grain structure. Sometimes only normalizing is final. Explain tempering and annealing in detail. Metals become brittle with increased hardness. Tempering is a post-process intended for toughness or reduce brittleness. Tempering temperatures are below steel's lower critical temperature. Heating time depends on thickness of material and temperature to which they need to brought. After sufficient heating they are removed from the furnace and allowed to cool in air. Hardness decreases and toughness increases with the increasing temperature of tempering. Steel is hardened to more amount than desired hardness intentionally to obtain desired hardness after tempering. And annealing is a stress-relieving process post-process of cold rolling, extruding, spinning and punching. Induces softness and ductility to enhance bending, shaping and machining. Parts are heated above upper critical temperature. After heating the material is allowed to cool in the close furnace. Why metal becomes formable after annealing. During cold rolling, as metal is rolled at temperature below recrystallization point, the grains become compressed, elongated and uneven. This causes the metal to become less formable. Because its hardness increases, observe in the image that compressed and elongated grains of metal have become more uniform after annealing. This change in grain structure makes the metal formable. What are the mediums for heating and cooling? Mediums for heating are air, oil, salt bath and some special chemicals. And mediums for cooling are brine or cold water, oil and fused salts. Explain the term recrystallization. Recrystallization is another reason for these property changes along with alloying. Old grain boundaries vanish and new grain boundaries develop. This process is called recrystallization. List various reasons of crack while heat treatment. Outer surface of plate cools faster than inner layer, leading to non-uniform volume change, excessive amount of non-metallic inclusions, quenching from high temperature to improper medium, time delay between heating and cooling process. These are the reasons for crack formation during heat treatment. Thanks for watching. Log on to dice.biz for more engineering tutorials.